Hello and welcome back. This is the first video of my experimental new series, I think. How to do this. In this series, I will try to explain some cool and popular use of IT stuff. Thus, this series will not be bound by any algorithm or technique. At first, I want to name this series how they do this, but then I think it will be too presumptuous to think that I know exactly how someone does the thing without them explaining it to me. Therefore, I decided to try to replicate the result of their work in my way and explain the process to the audience and name it how to do this. Modern AI has begun to spread in every sector in the past. We can imagine if the AI can do well in the sector or things. Some of them are deepfake and generated art by AI, music, poem, and drawing images. In this video, I want to focus on how AI generated stories after watching or reading several original stories written by humans. A few famous stories generated by AI are Batman and Harry Potter. In YouTube, these series have already been viewed a few million times, re-uploaded many times, and even animated several times by different content creators. If you want to try writing stories by AI like this, nowadays you can find tons of websites offering this service by simply Googling. We can start by simple Googling like this. And as you can see, we have a menu web that provide the service here. And we choose one, and to begin, we type like this, and this is the result. So to get the story, we must type some trigger word like that, and you get that. You can choose any other web, but as you can see, many of these services need you either to register or pay extra for more advanced service like specifying the genre, more wild story, etc. This is somehow not so convenient for some of us. Furthermore, we cannot force AI to watch a movie or read a novel and write an original story based on them. So that's why we will build our AI by ourselves in this video. Okay, first I want to talk about how this AI works. I will try to explain this clearly and simply, but not any simpler. Okay, the AI to create this artwork is come from a class of models called neural network. Some of you may not be familiar with this name, but a lot of you may be often hear about deep learning, right? Or maybe not. Deep learning is the model of all smart AI. This is the model behind deepfake and AI generator. Basically, deep learning is a neural network that has a lot of layers. This model has a lot of variants, but for this case, normally we will use either ERA-NAND, LSTM, GLUE, TCN, or transformer-based model. All of these models are complex, and that's why we will treat them as a black box. What we care about are the input and output. When they say they ask the AI to watch or read something, they refer to training the model. Training is set of algorithms to make the model memorize the pattern. I don't want to say the model understands the pattern because of how it works and how easily this model can be tricked. Now, the focus is on the dataset. Here, for our study case, we have the text of few Marvel superhero movies dialogue combined here, which we will use in the hands-on in this video. Now, how the model trained is through some set of mathematical operations. But we have a literal text here, right? How are we doing the addition, subtraction, or multiplication using words? We change those texts to the numbers. Okay, before doing this, we must split this text to get an array of all words included in the text. This process is called tokenization, and the words in the array is called a token. So now we will convert this token of word to some number. One of the most used techniques to convert words to some numbers is called one-hot encoding. To understand this, imagine we have a world dictionary for all English words. Our dictionary has approximately 17,000 words. All of these words will have an index. So, for example, the word video has an index of 100. To represent this word to the number, suppose we have a vector with a length of 17,000. All of the value in this vector will be 0 except the value in the index of 100. The next is the word it. with index 2. Analog with video, all of the value in its vector will be 0 except in index 2. Now imagine if we have a sentence with, let's say, 10 words, then we will have a matrix representation for this sentence with the shape 10 times 17,000. Instead of using word as an input, some model use characters. So in the case of our earlier dataset, mixing story of Marvel superheroes, we will extract all of the characters available in the dataset. Thus, the token will be in the form of characters for this case. So here I already built a script to doing this tokenization, and as you can see, this is our sentence that I already mentioned, and then here I split this sentence to the words, and then after that we built a dictionary like this, and then after that we built a matrix, and yeah, that's the process. And as you can see here, we get the matrix with the shape 14 times 13, and here for the character tokenization, here I just split them for every character and build a dictionary, and then build a matrix like this, and the result will be like, here we have the 15 times 24. Okay, now we will fit all of these words or character transformed into the matrix to our model. This is the process of what they say forcing bot or AI to read or watch movie or novel. This is the training phase begin. To make the model know what is right and wrong in the training phase, we must have a dataset in which the content is set of question, which is in this case a set of incomplete sentence in the end, and the set of answer, which are the continuation word for the sentence. Remember, all of these sentences must be transformed into a set of matrix, and because we will have not only one sentence but many, imagine this is an array of matrices. Now you understand the general idea of how to ask AI to learn. Now let's choose the model we will use for our experiment. From the three options of model I mentioned previously, let's choose TCN. TCN, like any other AI model, has many hyperparameters. This is the term for the configuration of the model. We will not delve into them because, like I said previously, in this video, we will treat the model as a black box. I will give an explanation about all kinds of AI model in another video. I choose the hyperparameter setting based on trial and error. Between char-based model or word-based model, I will choose char-based model for this because the size of the matrix will not be too big. Unlike word-based model which have nearly unlimited collection, two big matrix being processed can make my machine can handle the computation load. To train this model, CPU usage will make us wait long time for the training process. This is because there's a lot of computation steps done by the computer when in the training phase. Ordinary CPU only have a few cores. However, GPU or graphical processing unit, a CPU for showing GUI in our computer, has thousands of cores, although a single processor of GPU cannot be compared with a single processor of CPU. The use of GPU allows us to do a lot of computation in parallel, so the training process becomes faster. I am not so patient person, so I train the TCN. I will use GPU. Unfortunately, I am not installing the GPU file needed on my computer, so I will train the model in Google Colab. Here I limit the training data for the model because using full dataset, the training phase taking very long time to finish. I hope we get a good result. In theory, it will be very impactful for the model. And yeah, it's finished. Now we can just generate the story. Oh yeah, the system in here is the prediction of the model. So the model here is predict a character one at a time. So each prediction will be inputted to the model again, and it will be predict the next character. So go on. So it will be looped to the 1500. time. So this script will be generated a story 1500, yeah, 1500 character. Okay, let's try this. This is the my previous experiment. Let's change this. Okay, this is the same with the web generated AI story that we tried previously. So we provide the trigger word. Hello, this is trigger. Okay, let's run this. Oh yeah, this is the hyperparameter that I am using for the model. Okay, let's run. Let's check the result. And what is this? This is total fail. Looks like our model is fail, and looks like the limitation of training data we use is very impactful. As you can see, the model here is fail to predict. This is just random character. Yeah, looks like our TCN is failed because the limitation of training data we use. But it can be helped if I'm using all training data in my first try. It never in my first try it never finished. So you know that in Google Colab, if we using the GPU, it will be have a limit. It will be have a time limit. So in my first try, because it taking very long time, it passing the time limit. So the training page is never finished. So yeah, it can be a help, but now think about this. What we really do is just a predict character based on early character. Now how about we build a very simple model based on this definition? We only use a big dictionary to memorize all question, all answer. We can save all of this combination available in the dataset into the dictionary and voila. That's all we do for the training. And this is the script I'm talking about. Here I am open the training data and then record the character set available in the dataset, and then here I am build the very big dictionary, and then after that we provide the trigger sentence, and then it will be generated a story. Okay, let's test this. Let's test just this is trigger. What's the result? Okay, run this. And you see here, this is something like a cryptic message. Looks like this is another fail, but the unique with this model is, so in here I can create a model AI that can create a new original story by him, but actually this model can remember the story that it's already in the dictionary. For example, here I will copy the story in here as the input, as the trigger word for the input. You see here, this is the 80 input, and then it remembers the story in the training data here. So yeah, we failed to build a model that can create an original story based on the training dataset, but what we really create is a model that remember every story in the training dataset. So yeah, we still fail. Now, actually, we can use any pre-trained model for our case. We can use generative pre-trained transformer or GPT. Unlike the CN we used earlier, what's the meaning of this? So, even without training, we can already use this model. But still, if we want to produce a specific genre or story, we still need to train it at some level. And here I am using the repository of GPT-2 Simple. I'm using the Google Colab. You can just use this. Just change the training data in the Google Colab and retrain the GPT to simple. After that, just wait. Now I already finished the training phase. Let's load the model. First we must run this first. Okay. And this is the section for the random generated story. Yeah, in here looks like we don't need to provide some trigger sentence, but I think it's generate random trigger sentence in the inside. So yeah, it resulting it like this. Wow, this is looks like we success. This is just quote unquote decent story, not like in our two previous try. I am a singer, a dancer, a single wife. Scott saw up placed in his puffy orange blue and unclipped the Ravager outfit and goes walking. Scotland. I live placed in plaid looking armor, Beggar and etc. Looks good. And here we can provide the trigger sentence. And looks like we have a few parameters. For example, temperature here. So the higher temperature, the crazier the text. So if we setting the temperature is high, the prediction will be more wild or maybe be more crazier. For the prefix or the trigger sentence, let's say that Spider-Man died. Oh, okay. Another waiting. And this is the story that we get. Spider-Man died on the job, not breathing. Thor snatched Captain America's shield away, closing the gap as Hulkbuster carried Titan of army with magical energy. Bucky leaps and stuns T'Challa. What? Bucky leaps and stuns T'Challa with his hammer, then swing a shield him that can be kicked, cause he and his hammer are choked by the charging legs. Oh, looks like in this story everyone have a hammer. Charging through the air with the vibranium soul stone, will the power and space stone separate him and grow into bigger vibranium soul stone as time goes on. What was about to fire the last arrow at the Thanos we know and love. So in this story, Thanos looks like the protagonist that we know and love. Thanos keeps blocking fire with electrical cord using vibration when he lived for 1,000 years. What the fuck? Oh, this is the second story. Spider-Man died. So as you can see, the prefix here will be always the first sentence as the trigger. Spider-Man died in his sleep along with dozens of others last month when his nanotech intelligence blew up in nuclear holocaust. Dr. Arnim Zola is not about numbers, it's about God. He extends a nanotech strand and wire hangs off his arm. This is the third story. Spider-Man died, but I'm sure Auntie Peggy will find some way to get him to stay. Quill, I guess I prefer the dark tracks. You know, I was hoping he'd stick together as a couple, but he's going for pill or two. Quill, I reckon he just had pill. This is another story. Spider-Man died and Steve was bullied in Earth soil. So, Spider-Man died, but the bullied one, not Spider-Man, but Steve. Good. On the floor. Oh, so you have a girlfriend here to protect herself. Drax. He beat me because he wanted to kill him. Drax. Quietly. Yon, do you kill your father because he was young and beautiful and wanted to kill him, huh? And yeah, looks like in this experiment we success to generate quote-unquote stories. Yeah, quite absurd stories. And that's how to do that. The story generated by this AI can be so absurd. Because it's so absurd, people sometimes find it very funny. Now, go build your own AI and generate your own story. As you can see, many content creators on YouTube use this and he adds a lot of views because the story is hilarious. See you in the next video. Bye.